Hi everyone. Now we talked about discontinuities before, we kind of highlighted, what it is, but then now let's focus on the types of discontinuities that we can have. So if we look at this graph over here and we can tell that at x is equal to 4, we can tell that there's a discontinuity. We can tell that, listen, it's either 1 point at like 3.5 or it's 2. So I have a left-handed limit that's something and a right-handed limit that's something. So it looks like, I don't have a general limit. It doesn't exist because I'm approaching 2 points at one time. So over here, when we're at 1 point and we're kind of like jumping to another, we call this the jump discontinuity. Okay. So then immediately you can look at the next point. You can look at as x approaches 5 and tell me what kind of discontinuities that is. So again, whether it's filled or not filled, so whether the function exists at x is equal to, for instance, in our case, x is equal to 4 from one side or not, whether it exists or not at that point, as long as there's two kind of limits approaching from one side and then approaching from the other at the same point, you call this a jump discontinuity at that point. Okay. So then over here, we're looking at x is equal to 5, and the function doesn't exist at x is equal to 5. But again, when we're looking at those, at the continuity at this point, well, it doesn't again, we're jumping from one point to another. So the function isn't continuous. To call a function continuous, we need to make sure that it is smooth, right? Like you've said this before in class, probably, it's a smooth function. It can run without you removing your hand off the paper. So as long as we cannot, as long as we're doing that jump, then we call this a jump. So over here, as I was going, oh, yikes. No, I don't want to erase that. As I'm going like this, then I need to jump, remove my pen and kind of continue again like that. So again, we call this a jump discontinuity. Okay. Now, if I were to continue over here from 5 all the way on to 7, right? So as I'm approaching 7, I can see that I'm approaching it going infinitely upwards. So we call, but then on the other side, I'm not just going all the way up and kind of eventually touching those 7. No, I'm never touching 7. So 7 doesn't exist, right? So my function is not continuous at 7 because we can see that over here, it's approaching infinity on this side, and then on this side it's approaching negative infinity. So again, I had to remove my pencil or pen, but because I'm going to an infinite limit, or I'm going infinitely upwards or infinitely downwards or whatever, we call this an infinite or essential. So we call this an infinite or essential limit. Discontinuity, sorry, not limit. We're looking at continuities over here. So over here, we call this a discontinuity that is infinite or essential. And then if I were to look at my next one where we're looking at x approaches 9, so as x approaches 9 again, if I were to kind of approach 9 like that, because the function doesn't exist, right? If this is representing function f, we're going to say f doesn't exist at 9 because F doesn't have a point. You can see that there's a hole there, right? So we call this a point because it's just one point that has this continuity. So we call this a point discontinuity, or, a removable kind of, because you just remove and then continue. So a removable discontinuity. Okay. And it's removable. And it's basically just, all right, I'm going to remove my pen, but then continue on the same path. So over here, this is what we call a point of removable discontinuity. And then, we know that with the limits, we said that the limit exists when we're looking at this cusp over here, right? We said that a limit exists. Now let's look at whether, and we know that if the limit exists, then it is continuous. So over here, we can tell that, you know, there is no discontinuity, right? Because it's not, we're not removing it, we're not jumping, we're not going to different infinite limits, or, you know, we're not going to infinite directions. We are continuing along the path. So remember, to define something as continuous, it is, you know, we're going along, I just don't remove my pen. So over here, this is not any discontinuity. This is actually a continuous point at x is equal to 10, okay? All right, so these are the different types of discontinuities. You have jump discontinuity, where I'm going from one point, going along, and then I have to jump to another. That's jump discontinuity. Infinite is when we're going infinite, you know, we're going towards infinity at that point. X is equal to 7 in our case. And then a point discontinuity, or a removable discontinuity, is when I'm going along my function and then I jump, sorry, not jump, and then I kind of just remove my pen and then continue on again along the same path. So that's called a point or removable. And then when we're looking at cusps, I know it's tempting to say, oh, you know, it's not differentiable there, so it's not continuous. But no, that's not the case, right? And if you look at your definitions, we can tell immediately that um, the limit exists over here, and we can see that by the idea of discontinuities, where I have to remove my pen, you know, I'm not doing that, so then I can immediately see that it is continuous at this point. Okay. All right, everyone. I hope that helped, and I hope I'll see you in the next video. Bye.